So this is lesson 1.10, conversions. This would be a very fun one, and the first thing we're doing is performing algebraic manipulation to solve equations.
And then we're going to teach you to construct conversion factors from equivalent measurements.
Use dimensional analysis to convert one unit to another.
And end by showing you how to apply dimensional analysis to solve problems. So this is math that you're familiar with in some ways, but we're going to look at it in a little bit different way maybe than you ever have before. In chemistry, you definitely want to read chapter 2, section 2.5, starting on page 44, to go along with what Mr. Hunter and I are going to present to you.
Alright, so the biggest hiccup that can happen in chemistry is if you don't remember algebra, or just don't want to remember algebra. So to solve equations in chemistry, you have to be able to manipulate them using algebra to put the unknown variable by itself on one side of the equation. So our standard of doing this is to solve before substituting in the numbers, which means also you have to substitute both the numerical value and the unit once you do substitute them. And then lastly, units are treated like variables, meaning they have to stick around and move with the number they're attached to, which means dimensional analysis, the units remain and must carry over to the answer.
And we'll explain more about the dimensional analysis as we go on, but that's basically how we treat units.
So a real quick one, we have density written there. We'll cover density in more detail later, but that's D equals M times V. If I wanted to solve for V, I would multiply both sides by V. V cancels over here, and then I would have to divide by D on both sides. So I would get V, cancels here, equals mass divided by density. And that's just where you would start, and from there you would plug in. It's simple algebra. Remember, you have to divide by things that are up in the numerator and multiply by things that are in the denominator to get rid of them. You can't add and subtract in this case.
So the key tool that you're going to use in doing any conversion of one unit to another is what we call a conversion factor. And a conversion factor is simply a fraction that's got two things that are equal in the numerator and denominator. So the value of a conversion factor is always 1 because you're dividing something by something else that's equal to it. And you construct them in such a way so that you get rid of the unit you want to get rid of. It divides itself out, and the unit you want to end up with remains. So let me give you a very simple example with something you're already all familiar with. So we know that 1 foot is equivalent to 12 inches. That is an equivalence relationship. So those two things, 1 foot and 12 inches, are equal to each other. So we can express that in a fraction form. We can say 1 foot over 12 inches, and that's a conversion factor. Or we could write it as 12 inches over 1 foot in the denominator, and that's another conversion factor. So we would choose which one of these two we wanted to use based on what unit we were given and what unit we wanted to end up with, and getting the units to cancel out so that we end up with one unit or another. And we're going to illustrate that on the next slide. But basically the key concept is here taking an equivalence relationship and being able to make a fraction called a conversion factor out of that.
So let's actually look at a unit conversion. As we discussed before, we have to have a process. And we want to know how many kilograms are in 35.7 grams. So the first thing you have to know is what relationship those things have to one another. And one relationship is that for every 1 kilogram, that equals a total of 1,000 grams. So that is our relationship. We then have to take that to a conversion factor. It's going to be one of two things. It's either going to be 1 kilogram divided by 1,000 grams, or 1,000 grams divided by 1 kilograms. So then we have to perform our dimensional analysis. Alright, I do dimensional analysis a little bit different than Mr. Ferguson. I use what's known as the fence post method, and that's because it literally looks like a fence post. Right here we have our starting starting given value of 35.7. And then I have to add in this conversion factor in the manner that will allow me to cancel out my current unit, which means I need to have grams and kilogram. And the way you use this is you multiply this way and you divide down. So as it's written right now, my grams are going to cancel. I'm going to take 3.57 times 1 divided by 1,000. And the way Mr. Ferguson would write this would be 3.35. Let's try that again. He would take 35.7 grams, and then he would use this 1 kilogram divided by 1,000 grams. Again, your grams are going to cancel, and then we have to figure out what the answer should be. So 35.7 divided by 1,000 will be 0.0357 kilograms. And since we are dividing, we have to figure out the number of sig figs we need. Now right here, these values here and these values here are known as given values. They do not affect significant figure calculations.
Because they are considered to be perfect numbers,
Yes.
so they have an infinite, it's 1.000 with an infinite number of zeros. Kilograms equals precisely 1,000, the perfect number of grams.
Yeah. So in this case, we have 3 sig figs, 3 sig figs. We're good to go. Let's take a look at some more.
All right, so let's take a look at a slightly more challenging example. So a student has a lab bench that measures 6.30 feet. That's the symbol for feet. The student's instructor wants to know the length in meters. The instructor tells the student that there are 2.54 centimeters per inch. So we have a couple of equivalences here. We're given feet, so we already know that 1 foot equals 12 inches. We are also given the equivalence between inches and centimeters. So we're just told in this last statement right here, 2.54 centimeters per inch means that 1 inch equals 2.54 centimeters. So those are two equivalence facts that we're going to need to know. And then we're also asked to give our final answer in meters. What would be helpful to be able to recall that 100 centimeters is equivalent to 1 meter. So keep those three in mind. We'll start with our given, 6.30 feet. Okay, so we can do this according to the fence post method, or we can do it by multiplying by conversion factors. I'll set it up as a fence post problem. So the first thing we want to do is cause the unit of feet to divide out to give us something that's more useful. All right, so I'm going to employ this conversion factor right here. 12 inches equals 1 foot. And I can set it up either as 12 inches on the top, up here, 1 foot on the bottom, or I can put 1 foot up here, 12 inches on the bottom. Because we want to cancel feet, I'm going to put 1 foot here, and I'm going to put 12 inches there. That causes the unit of feet to divide out. Anytime a unit appears in the numerator and the denominator, it effectively divides itself out. So we now have the unit of inches. Now we want to move from inches to a metric unit of centimeters. So again, I'm going to build a conversion factor out of this relationship. And I want the unit I want to get rid of on the bottom, so I'm going to put 1 inch down here. And I'm going to put what's equal to 1 inch, which is 2.54 centimeters, up here. That causes the inch unit to divide out. So our unit is now centimeters. If we stopped and we calculated out the answer right now, we would have the number of centimeters equal to 6.30 feet. But the question asked us to supply the number of meters in 6.30 feet. So we need to use this last equivalence. We want to end up with meters, so I'm going to put 1 meter on the top because that's generally where the unit that's uncancelled at the end ends up, and what's equal to 1 meter, which is 100 centimeters, goes down here. Centimeters will divide itself out. Mr. Hunter, can I have a little calculator help here, sir?
I suppose you can.
Okay.
So 6.3.
Mathematically, we take the given, multiply it by 12, multiply by 2.54, divide by 100. I don't really do anything with the ones because multiplying or dividing by 1 doesn't change anything anyhow. So we have 1.9024. 1.9024. Now we have two things we need to do. One is look at our significant figures in our original measurement. Two is make sure we get the correct unit on.
Yep.
So our original measurement had a 0 at the end, decimal points shown, which means that's significant, so there's 3. So I want 3 significant figures here, so my 1.9024 I'm going to write as 1.90.
And all our units cancel out but meters.
So the only unit that's left comes right over onto the answer. 1.90 meters is the number of meters that's equal to 6.30 feet.
Okay, let's look at your last slide. So here's your PVQs for this time around. They want you to do some rearranging for numbers 1 and 3, and they want you to do a conversion for number 2. We'll cover these tomorrow in class to see how well you did. Good luck.